In this video, I'll be going over some tips on how you can calculate your measures of central tendency in our Module 2 lecture. So the slide in question is this one, where I've given you a simple frequency distribution table of how many pull-ups a certain number of people were able to perform. Okay, so the first measure of central tendency that I think is the easiest for us to pull out from this particular organization of our data is the mode, right? Which is the most frequently occurring value in our data set. Now, in this table, we can see number of pull-ups. So this is the actual data that was collected. And then in the second column, we can see the frequency at which each of these values occurred in our data set. Right? So automatically we can see that 11 is the largest value in this frequency column, indicating that 3 is the data value that occurred the most. That would mean that our mode is the value 3. If we want to find the mean and the median, however, we can't use this organization of our table. Or we could, but it's just a little bit harder to calculate. Also, Excel has functions for both the mean and the median, which makes our lives a lot easier. So in terms of calculating these two, we just need to reorganize the data in a way that we can use those functions in Excel. I'm going to do this by copying the table in the PowerPoint. And then you'll just open a blank Excel workbook and paste the table in the workbook. Now, at the bottom you'll see a paste options. I'm going to match the destination formatting. That way my table isn't outrageously large. I'm also going to change the notation of number of pull-ups so I can see the full label. Okay. So what we can do now is recreate or reorganize our data to show up as it would if we had collected it on a bunch of subjects, right? So typically what we would see is a subject number and then the data or the dependent variable that we would be collecting, so number of pull-ups, right? And we could make a subject list from 1 till whatever, right? Technically, we don't really need this subject list. I'm just going to make a number of pull-ups section, but if you want to imagine that one subject is attached to each pull-up value, and that helps you, then that is great, okay? But we're going to move down the list, so we want to do an ordered list, right? And we're going to move down from the first pull-up value 1, and we're going to type that number or type that value the number of times that it occurs in our data set. So 1 occurs twice, therefore we are going to insert 1 2 times in our distribution start. Okay, the value 2 occurs 5 times, so we can put the number 2, right, and copy it down 5 times. You can double check your count by looking at the count little bar at the bottom. The number 3 occurs 11 times, so we should roughly be somewhere around here. I need one more. Okay. Number 4 occurs 9 times. Whoops. Okay. The number 5 occurs 8 times. And you can kind of see where this is going, right? Okay, the number 6 occurs 6 times. The number 7 occurs 5 times. The number 8 occurs 3 times. Nine happens twice. 10 happens once, and 25 happens once. So now we have this nice long distribution, okay, imagining that each value belongs to a single subject. And we can calculate the mean pretty easily. We've actually used this function before in our activity 1 data set. And if you recall, our Excel function is equals and then the word average. So we can start typing this in, choose the function, and then we want to take the average of the number of pull-ups that were completed by our subjects. So we insert that cell range, we can press enter, and we get an average of roughly 5.1. So the average number of pull-ups that were able to be performed by this data set, right, either in our frequency distribution or written out in its entirety, is 5.1 pull-ups. If we wanted the median, which is the middle number of the data set, remember that a median needs to be coming from a rank-ordered list, right? So if our values go from one end of the spectrum being the low or the minimum, we order them all until we get to the max value. Okay, so the middle of our distribution is noted by the median. Remember, if we have an odd number of values, we take the exact middle number. If we have an even number of values, we take the average of the middle two values. The nice thing about Excel is it actually has a function that will calculate the median for you, regardless if your data is in rank order or not. However, this organization, the way that we built this data set off of our frequency table, it's already rank ordered, so it really doesn't matter. But if you're calculating this by hand and you want to define the center value, then you could do that. If not, we can use the median function. You can see it pops up here. And then we simply insert the range of data that we're interested in finding the median for. Press enter, and we can see that the median value is 4. Okay. And then again, we said, just so that we have it here, our mode was 3 because it occurred the most frequently. The other set of instructions on here is to create a line or a bar graph to represent your data. Similar to activity 1, when we built a graph off of a simple frequency distribution table, we're going to highlight our frequency column. We click insert, and then I am giving you guys the options to visualize either with a bar graph, which would look something like this, and then we would need to change our x-axis values, which we can do by selecting data and changing our horizontal axis labels to the number of pull-ups that they correspond to. Right, so then we have 1, 2, 3, 4, 5, 6, 7, 8, all the way to 25. Our other option is a line graph. So if I click out of that, I can insert a line graph, and I'm going to do one with markers just because I think it's a little bit easier to visualize. Okay. And then the same thing would go if we wanted to change the horizontal axis labels to match the data that we've collected. Okay, so in a nice graph, we could say let's make our values go 1 through 25 by units of 1. Since we're using premeditative labels that we've already created, we can't exactly make those edits in here. But I still think that the visualizations that we've created, for the most part, give us an idea of what the shape of our distribution would look like. Okay. So if we had values between 10 and 25, this line here would be really, 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 really long, right, until we got to 0.25, right, which is over here. So if it helps you to visualize like that there would be a gap here, you can do that for yourself. But this is generally what our distribution looks like, right? The line graph and the bar graph both represent that we've got a bit of skewness going on, likely due to this outlier 25, right, which only occurs one time.